What is your personal favorite ARM-based device?
Yeah, so lots of. So I have my cell phone, I have a lot of embedded products that I have. Also inside my car, my infotainment system has a lot of ARM products. I think I could spend the whole day talking about the ARM-based products that I use.
Describe the future of computing in one word.
I would say exponential. So it has been exponential for the last decades, Moore's law and everything. But now it's more in direction of AI and computer vision again. So it's continually scaling up.
On a scale of 1 to 10, how excited are you about the future of computing?
I would say an 8. I think we are in the right way, but a lot of challenges coming, especially regarding AI and computer vision.
What do you see as the breakthrough technology in the next decade?
I think for sure it's AI. Everybody's talking about that, so in different fields. And in my field also for autonomous driving, that will be a breakthrough.
What will have the biggest impact on technology over the next decade? AI, the metaverse, or ambient computing?
Again, so I'm biased because of autonomous driving, but I think AI will be the main breakthrough for the next years for sure. And yeah, for the whole industry in general.
Augmented reality, virtual reality, or mixed reality? Which has the biggest potential?
Mixed reality is very nice for autonomous driving. We started with small steps like head-up display and so on. But I think this is increasing. We can have smarter sensors, smarter displays, and the mixed reality will be very soon in the automotive industry a reality.
If you could choose between more performance or more performance per watt, which one would you choose?
I would choose more performance per watt. So we all have, for example, in autonomous driving, batteries in the cars. EVs need, autonomous to reach a good distance. Without, performance per watt, we cannot reach it.
Some analysts predict that automotive will be the most important sector for driving semiconductor growth. What part of the vehicle drives this growth in particular?
So I think AD and others will drive the most because here is where we need the most performance. But fields like communication will drive this also, as well as infotainment. So everything is growing exponentially inside the car, and all of them will drive the growth.
On a scale of 1 to 10, how big of a challenge is security across connected devices?
Oh, I would say a 9. It's really challenging. So now we have everything connected. We have IoT that's also coming inside the car. We have vehicle-to-vehicle communication, vehicle-to-everything communication. And this leverages the safety risks in a really, really high level.
Is Moore's law really coming to an end?
I think it's going to another direction. So we are reaching the limit of silicon, but we are starting with new software architectures. We started with this diversity of computation. So I think we have the Moore's law, but not in the classical way. We have the Moore's law in different ways now.
It seems everybody is pursuing more performance despite the murmurs of Moore's law ending. What do you think will drive the most performance rise when manufacturing chips? Would it be novel materials, 3D-enabled designs, or the simplification of processor instructions, or advanced packaging?
Again, I think it's a mixture of everything. So we see, for example, high bandwidth memories as a reality today. I see that 3D stacking could be a reality also, but one of the solutions alone cannot do it, right? So I think if we combine most of them, we can go beyond and reach new levels of performance.
What will experience the biggest evolution over the next decade for you, software or hardware?
I think software, right? So the whole software is changing because of AI, because of computer vision, because of safety, and we need to change the software to accommodate this. So the challenges are immense, and I think software will change a lot.
What will be the best place for future processing needs, the edge or the cloud?
So again, I'm biased because of autonomous driving. So I think we have to do everything local. So we cannot rely on the cloud to make the decisions for driving. If we have latency, if we have connection problems, that would be a huge safety risk for the car. So I think we have to do everything local.
Where do you see most of AI taking place, the edge or the cloud?
I mean, it's different, right? So for autonomous driving, like I said, it's on the edge, but in general, I think the cloud is also very important. We cannot do everything inside a car. A car is not a server. And for training, for example, we need the cloud, so it's a mixture.
There seems to be a rise in OEMs designing their own SoCs. What do you see as the main driver? Is it differentiation of features, design flexibility, or supply longevity?
I think a little bit of everything. So we need, unique selling points. The whole industry is looking for these differentiation positions. The whole software is made for hardware and vice versa. So we need this kind of new environment, and the system chip environment makes this possible.
What will be the single biggest challenge in computing over the next decade?
So again, the scalability. So the amount of processing power that you need for level 4 of autonomous driving is immense. At the same time, to reach this with a low power design, it's challenging. So we have to find here a sweet spot, and it's not very easy to find.
When you think about the next 10 years, what one computing trend will fuel your company's growth the most?
For autonomous driving, surely computer vision and artificial intelligence. So this will make possible to reach, level 3 and level 4 of autonomous driving. We are very active researching these topics and make the next step possible for the automotive industry.
What's your favorite thing about ARM technology?
Since I mentioned it, so the functional safety capabilities of ARM are really important. So we are talking about autonomous driving, we are talking about huge failure risks that could happen inside the car and that could lead to life loss. But I mean, you have a lot of capabilities for functional safety. We use this in every day already, and this is really necessary to reach the security that we need inside the car.
How important is ARM technology for your future roadmap?
Yeah, I would say 9 to 10. So we are really committed to drive the future of computational effort inside the car, and here we see ARM as a potential partner, really huge regarding CPUs, functional safety island, and other aspects inside the car.
Roughly how many products do you have that are ARM-based?
So ZF is a huge company. We have thousands of products, and for sure more than 100 products are using ARM-based technology right now.
Do you have a favorite memory working with ARM that you could share with us?
Well, I mean, it is a really recent memory, but this is my first ARM partner meeting, and it was really impressive. I like the level of professionalism regarding keynotes, regarding the organization of the meeting, the meetings that we do here inside, the new partners that I met here. So although it's happening right now, it will be for sure a good memory